Hello everyone, my name is Rizwan and welcome to the Nowhere. So today we'll be solving question number 225, which is implement stack using queues. So first of all, what we have to do, we have to use the LIFO concept. That is, we have to use all the functions uh, that are used in the stack inside on a queue. All right, and the queue should act as if it were a stack. So for that we have to use two. It is given here. This problem can be used by can be solved by using only one queue. But as we are given, it is given the question that we have to use two queues, so we will use two queues. All right. So first we'll create two queues. First one is I have created here self.queue, which is queue, and another is self.simply queue. All right, is equal to dq. I have created two queues, and what I will do here is the concept here is like this. So all the functions like push, pop, mm, and whatever top, empty, all the functions that can be used on a stack. All right, should be used on a queue, and the queues should act like stacks. All right. So the so we will move forward, and I will try to build on that furthermore. So for example here, if we have to append any integer x to q1, so where will it get appended? It will get appended here. But we know that it is a queue, and that's not how it is going to happen here. All right. So whenever queue will get appended, it will get appended here. The most recent element will be the first element, not the last element. So if it gets appended at last, then it is a stack. It will act as a stack. If it gets appended at first, you know, so it will act. It is a queue. So in order for it to act as a queue, then the element should be appended at the first index, right? That is 0. Okay, now it is acting. Now it is a queue. But when we append x here, all right, when we have appended x here, is it at the top of the stack? Or sorry, is it at the top of the queue? No, it is not. But how is it going when we are going to use pop function? So it should basically, the pop function eliminates the top of the stack. All right, whatever is at the top of the stack, it should, in theory, it should eliminate x. The pop function should eliminate x. But is it going to eliminate x? No, it is not going to eliminate x. All right, it is going to eliminate 4. So it is not going to act like a stack. All right, the function should act like a stack. So what we'll do is we'll create another function. So we will append x directly into the next into the q2, which is the second queue. All right, so we'll append it directly inside x. Okay, sorry. Okay. So what will happen next? And then we will start appending, Q2. Uh, we will pop the Q1 from left by using the pop left function. So remember that we will pop the Q1 from left by using the pop left function. All right. So, and it we will append directly to the Q2. So it will go like this. So 1, 2, 3, 4. So Q2 will act like this, and this Q1 will be empty. Okay, so now we have created a queue. All right. So this is how we have appended, how we appended and use. If we have directly would have directly appended it x integer to the q1, then what would have happened? It would have acted like a stack. We know that this is not a stack. So now we have transformed it completely into a queue. This is how a queue should behave. Yes. All right. So this is it. Okay. What's the next step? Now we have transformed this. So we will exchange the value. We'll exchange the assignment of the queues. So Q1 will become Q2 and Q2 will become Q1. So this will become Q2 and this will become Q1. All right. So another time we have Y. All right. So where we will append it? We are going to append it inside Q2 just like the first place, because now this is an empty queue and the places have been exchanged. So this has been assigned as Q2. So the Y will be assigned here, and same thing will happen. So after we have appended directly, we have directly appended Y inside the empty queue, which is Q2. So what we'll do then is we will pop the Q1, all right, from left. So sorry, so the elements will look like this: X, 1, 2, and so on, 3, 4. All right. So this is what it will look like. So this is how it is going to go. Okay, now, so now for the push function, all right. So for the push function, we have directly appended. So this will become, you can see X we have directly appended, Y we have directly appended inside Q2. All right. So this is the push function. This is what will happen inside the stack. Inside stack, when we push any element, or by which we mean that we append an element inside a stack. All right. So that's what we are doing here. We're directly appending. For example, in case of X, we appended Q1. All right. At that time, this Q1 was Q2. All right. So always we are going to append Q2 once the operation is completed, once one iteration gets completed. So the Q1 will become Q2 and Q2 will become Q1. And this operation, this cycle will continue until the stack is empty. So for the second operation, uh, which is pop. So for the pop function, what are we going to pop? We have to pop Y. So this is the whatever is at the first, whatever is at the zero index. So that will get popped out. All right. So so for the as we mentioned earlier, for the pop function, what will happen when we implement the pop function, we have to pop the element that is at zero index. So in case of stack, if this was a stack, Y would have been here. All right. Y would have been at the end. But for it to act like a stack, and the pop function would have removed the element which is at the top of the stack. All right. But we know that this in queue, the element is not going to be at the top. It is going to be at first, for at the entry point. When any element that is going to be added will be at the entry point of the a list or array. Right. So this is a queue here, and when we pop this, this will act as a stack. It will act as if it has the same operation has been done on this, uh, as if it were a stack. So also the second, what is the next operation, which is top? Also we know that we have to do what will be at the top of the stack will be at the will be the first element of the queue. All right. So here, okay, I'll go through. Yes, this is the push function. What we have to, as I told you earlier, that the Q1 for each cycle, after completing one cycle, that Q1 will become Q2 and Q2 will become Q1. So our Q1 here is Q, and our Q2 is simply Q. So we have an integer here x, and we have to append it. We directly appended it, self dot append x, and while self dot q, it means that q is not empty, which means self dot q, we have to append whatever q self dot q dot pop left, whatever is at the end, whatever is at the entry point of the queue. The first element of the queue will get popped out, and it will be appended to the queue. All right, and this will continue until it becomes empty. And after the operation is complete, and then the queue will become Q1 will become Q2, and Q2 will become Q1. So same thing with the pop. What will happen in the stack? So at stack, when we say pop, the end, whatever is at the top of the stack will get popped out. All right. So, but in case of, we know that we're dealing with a queue. All right. So the first element will be at the top of the stack, but the first element of the queue will be at the top of the stack. So we will have to we have to pop the first element of the stack. So which will be pop left. All right. So this is how it is going to act. All right, we know that what is at the top of the stack will be, as I told you earlier, whatever is at the whatever whichever one element is at the zero index, which means whichever element is first, then it will be at the top of the stack. All right. So we have to. This one is easy. We have to check whether or not the queue is empty or not. If it is empty, then it will return two. Then if it is not empty, then it will return false. So I hope I was able to make you understand. Please do like, share, and subscribe. And if you're watching this on Facebook, do follow the page. Thank you.